Hey Valley Metal, welcome back to another math video. Tonight's weekly enrichment assignment is going to have you using the distributive property to solve difficult two-step equations. I'm pretty sure by the end of this you're going to want to throw stuff at me because the problems are hard, but you can do it if you do it step by step. Let's take a look at the assignment. It's another one of these puzzle sheets, but take a look at some of the equations that we're going to have to solve here. Little difficult. Yeah, it's definitely a step up from the 6th grade work that we've been doing. So I'm going to model problems 1 and 6 here for you, and I think you'll be able to do this. Some things that you have to need to know. You need to know what gathering like terms means. In other words, if we have 3x over here and we have 4x over here, we can gather those together and say that that's really 7x. We're just gathering up the x's. And we've done that before. You can also do that with, like, if this was 3 and this was 4, we could gather them up too. We can gather those like terms. They don't have to have a variable behind it. All right, and you need to know how to distribute. So I'm going to go ahead and click here. Here's my little distributive. Whoop, I got to get my pen out. Sorry. To distribute this, we can take 3 times the x and we can take 3 times the 4. That's what the distributive property is we looked at way back in October. All right, so let's go ahead and first of all, we can't gather up any of these like terms yet, but we can distribute out that 3. So if I distribute that out, I have 3 times x and gives me 3x, and 3 times the 4 gives me the 12. So now if you look at it, we have x plus 3x plus 12 equals 20. Now I can gather up some things. I can gather up 1x and 3x and make that 4x plus 12. And all of a sudden, you're looking at a two-step equation, and you know how to solve those. So we'll go ahead and we'll subtract the 12, cross those guys out. These guys here will cross out. Sorry, get my pencil back. This will cross back out, leaving us with just 4x equals 8. We don't quite have that x isolated yet. 4x is multiplication, so we'll go ahead and we'll divide by 4, and it leaves us with x equals 2. Okay? Is our answer right? I have no idea. You can check it. You can take that value of 2 and substitute it back in to this equation up here wherever the x's were. There were 2 x's here and here. So I sub those in right here. I put the value of 2 in. So I have this distributive value here. This time I'm going to take 2 plus 4 first, and that gives me 6. 6 times 3 is 18, plus that 2 does give me 20. All right, let's take a look at the next example, and it's got some negative numbers in it. Yikes. All right, so there's nothing that we can gather up here right now, but we're going to go ahead and distribute this out. Let me get rid of that. That's bugging me. We can distribute this out. So we have a negative 2 times p. Well, we're going to have negative 2p, and nobody likes negative p. You know what I'm saying? All right, we also have, this here is actually minus 5, but I changed it to plus a negative 5. Because now we have to also distribute that negative 2 out times the minus 5 or times that negative 5. So 2 times 5 is 10, and we have 2 negative signs, so a negative 2 times negative 5 is really a positive 10. So this little distributive, when I distribute out that negative 2, I have negative 2p plus 10. And then I just add that 7p, and that equals negative 5. So now we have some terms that we can combine here. We've got negative p and positive p. Whatever. All right, so, but that's really negative 2 on the number line, and we add positive 7, we would be at 5p. Another way to think about that is you could just take the positive 7 and subtract that negative 2, or subtract the 2, and you'd have 5p. Now we're back to that two-step equation. We need to get rid of the 10, so we can isolate the p. We'll subtract 10 from both sides. That's going to leave me, we've isolated this down to 5p equals negative 15, because this is really a negative 5 minus a negative 10. Or I like to think about it as a negative 5 plus, make that into a positive, plus a negative 10. That helps me see that negative 15 much easier. I can cross these guys out too. All right, and now we divide by 5. We're going to cross these guys out. These 5s cross off as we divide. We end up with p equals a negative 3 because we have a negative 15 divided by 5. So 15 divided by 5 is 3. There's only one negative sign, so that's a negative 3. Just like the other one, you can pop that in and you can check your answer. It's a little more complicated this time, but I substituted in the negative 3, and I end up with a negative 2 times negative 8, so that's going to give me 16, because negative 3 plus negative 5 is negative 8. That's how I got that. So that's going to give me a positive 16, a negative times a negative. And then I have 7 times a negative 3. That's going to give me a negative 21. So I have 16 plus a negative 21. If you think of being at 16 on the number line and subtracting 21, you're going way over there to negative 5. Our answer does check out. I don't care so much about the puzzle, but it is kind of nice to know that you can look for your answers on here, and if you find them, then you know you're working correctly. All right, thanks a lot. I appreciate you listening. Have a great evening.